Hello, dear students. We'll start our lecture. Today is theme 9. Lecture by Technological Foundation of Mechanical Engineering. And theme 9, Technical Regulation of Technological Processes. Write down to your notes the theme of our lecture and the plan of our lecture. 9.1, Basic Concepts of Technical Regulation. 9.2, Structure of peacetime. 9.3, Technical norm of time. 9.1, Basic concepts of technical regulation. 9.2, Structure of peacetime. And 9.3, Technical norm of time. And we start item 9.1, Basic concepts of technical regulation. So, what is the technical regulation? Technical rationing is the establishment of a reasonable norm of time for the performance of a given work or the determination of the production of products per unit of time. Technical rationing is great importance. Technical rationing is the establishment of a reasonable norm of time for the performance of a given work or the determination of the production of products per unit of time. Technical rationing is of great importance for determining the main technical and organizational characteristics of production, the cost of production, the duration of the production processes, the amount of technological equipment, the number of labor, etc. The norm of time for the manufacture of a unit of production is the most important criterion for assessing the effectiveness of the organization of the production process. Time limits are set as follows. Based on the study of the cost of working time, timing of work, at advanced enterprises. According to standards, approximate comparison with similar operation works. The first two methods are used in mass and large-scale production, in the detailed development of technological processes. First, it's based on the study. Based on the study of the cost of working time at advanced enterprises. And second, according to standards. The latter method is typical for small-scale and single-piece production. For small-scale and single-piece production, it's method number 3, approximate comparison with similar operations. It is approximate since the time norm is set using standard norms for the performance of work for analog products. When determining time standards, shortcomings in the organization of production and deviations from normal working conditions should not be taken into account. Simple equipment, its unsatisfactory technical condition, untimely supply of workpieces, etc. Item 9.2, structure of peacetime. Structure of peacetime. The norm of time for performing the operation of the technological process of processing or assembling a unit of production is called peacetime. Please write down to your notes what is the peacetime. It's the norm of time for performing the operation of the technological process of processing or assembling a unit of production. It's peacetime. Peacetime for non-automated production consists of the main technological time, T suffix 0. The main technological time, T suffix 0. Peacetime, it's T suffix P, peace. Peacetime is equal. T suffix 0 plus. T suffix 0, it's the main technological time. Auxiliary time, T suffix aux. Auxiliary time. Time for maintenance of the workpiece, T suffix M. T suffix M. Time for maintenance of the workpiece. Or of the workplace, excuse me, of the workplace. Time for maintenance of the workplace. Next part of peacetime, it's time for organizational maintenance of the workplace, T suffix OM. And the last part of peacetime, it's time for breaks, for rest and physical needs, T suffix BPN. It's time for breaks, for rest and physical needs. So TP will be equal T suffix 0 plus T suffix aux plus T suffix M plus T suffix OM plus T suffix BPN. Its peacetime is equal the main technological time plus auxiliary time plus time for maintenance of the workplace plus time for organizational maintenance of the workplace and plus time of breaks for rest and physical needs. Please write down to your notes formula 9.1 and the parameters from this formula. The main time is the time during which the product is directly affected by the working tool. That is, changing its size, geometric shape, roughness, properties, appearance, etc. So, one more time, the main time is the time during which the product is directly affected by the working tool. For example, when processing a workpiece on metal cutting machines, the main time is chip removal time. On the cutting machine. For example, on the lathe machine. So the main time T suffix 0 is equal big L multiplied by E by I and divided by S suffix M. It's formula 9.2. In this formula, big L is the estimated length of processing taking into account the infeed and overrun of the tool. I is the number of working strokes of the tool. And S suffix M, minute tool feet. Minute tool feet in millimeters per minute. Minute tool feet. Write down to your notes formula 9.2 and the parts of the formula. For example, with longitudinal tuning, like in figure 9.1, the estimated length of processing, big L, it's this parameter from the formula 9.2. Estimated length of processing taking into account the in-feed and overrun of the tool. So big L is equal small l in the figure plus L suffix 1 plus L suffix 2. And you can see L suffix 1 and L suffix 2. It's big L, it's small l. So big L will be equal L suffix 1 plus L and plus L suffix 2. Where L, small l, is the actual length of the treated surface. Actual length of the treated surface. Actual length of the treated surface. L suffix 1. This distance. L suffix 1 is the length of the tool plangle. L suffix 2 is the length of the tool overrun. L suffix 2. And it's L suffix 1. Because our tool has the angle on the head. Usually we take that L suffix 1 is equal L suffix 2. It's for less machine, for tuning on the less machine. Please write down to your notes formula 9.3 and figure 9.1. You have 2 minutes to do this. And we start the next slide. The estimated length is determined in each case depending on the scheme and type of processing of the workpiece. Auxiliary time, T suffix aux, is the time spent as a rule on the implementation of auxiliary transitions, installation and removal of the workpiece during processing, starting and stopping the machine, changing processing modes during the operation, measurement and quality control of the workpiece, measurement and quality control of the finished part, etc. Please write down to your notes the parts of auxiliary time. Distinguish between overlapped and non-overlapped auxiliary time. Continuous non-productive time refers to the actions of the worker that are not in the process of processing. For example, setting or removing a workpiece or blank. Overlapped non-time refers to the actions of the worker or machine performed during processing. In this regard, the overlapped auxiliary time is not taken into account in the piece time structure. So write down to your notes parts of auxiliary time. The sum of the main and auxiliary non-overlapping time is called operational time. Operational time is the sum of the main and auxiliary time. Main time plus auxiliary time. Write down to your notes formula 9.4. The maintenance time, T suffix M, of the workplace is a part of the piece time spent on the following actions: changing and editing tools, adjustment of the machine during operation, removal of chips during the performance of a given work. It's the maintenance time. The time of organizational maintenance of the workplace, T suffix OM, is a part of the unit time spent on caring for the workplace during the shift. It includes the following steps: layout of the tool at the beginning of the shift and cleaning it after the end of the shift. Cleaning, lubrication, inspection, and testing of the machine. It's time of organizational maintenance. T suffix OM. Time of breaks for rest and physical needs, TBPN, is part of the peace time regulated by labor legislation when performing heavy and tedious work. Auxiliary time for this type of works is calculated according to its constituent elements on the basis of current standards. The time of organizational and technical maintenance of the workplace and breaks is determined as a rule as a percentage of the operational time. Thus, peace time is calculated by the formulas 9.5 or 9.6. In formula 9.6, T suffix 0, the main technological time. T suffix auxiliary, auxiliary time. T suffix 0 and T suffix auxiliary again, and coefficients A and B. A, the share of time as a percentage for technical and organizational maintenance of the workplace from the operational time. A is equal from 3 to 5% from operational and auxiliary time. B, share of time as a percentage for rest and personal needs from operational time. B is equal from 2 to 5%. It's B. So we can use formula 9.5 and we can use formula 9.6 to calculate the peace time. Write down to your notes. You already have formula 9.5 and write down to your notes formula 9.6 and parameters from this formula. If you have a questions about item 9.2, you can tell me or write in our Telegram group. And we are start item 9.3, technical norm of time. The technical norm of time depends not only on the actions carried out directly in the performance of a given work, but also on the duration of the preparatory and final work necessary to process a batch of work pieces or products. The preparatory and final time for a batch of products is intended for getting a job, familiarization with the work, adjustment of equipment and special devices, delivery of completed work, removal of special devices after processing, etc. Write down to your notes types of preparatory and final works for the preparatory and final time. The preparatory and final time does not depend on the number of products, but only on the complexity of the works performed, including equipment settings. In a single production, the preparatory and final time is included directly in the piece. In mass production, the repeatability of the work, performed is high. So there is no need for preparatory and final operations. In serial production, the norm of time for processing a batch of work pieces we can calculate using the formula 9.7. T P C N is equal TP multiplied by N plus T suffix PF. In this formula, TP is time, N is the number of parts in the batch, TPF preparatory final time. It's preparatory final time. In technical norm of time for processing the workpiece, T piece calculation is equal T piece plus TPF divided by N. N is the number of parts in the batch, and TPF is preparatory final time. The technical norm of time for processing one workpiece or assembling an assembly unit is often, especially in the organization of production, called piece calculation time. So piece calculation time is equal TP plus TPF divided by N, using the formula 9.8. Write down to your notes 9.7 and 9.8. So it was the last slide of our lecture. You have the time to finish these formulas. And have your questions about Theme 9. You haven't the questions, so our lecture is finished. See you next week on the next lecture. Have a nice day and goodbye.